All right, more notes. So you take good, careful notes on each of these problems. I know it looks like a lot, but again, it should take you between 20 and 30 minutes, depending on how many times you pause and rewind it. So what we're talking about here is a continuation of what we've learned over the last few days, and that is how to deal with zero and negative exponents. Some of this will be review, some of it will be a little bit new. So I'll point out when things are new. So getting right into it, we'll start with number 1. So here we have 7w to the negative 4. One thing to always be careful of is just knowing what is the base. So what is the thing that is repeated by the exponent? And unless there's parentheses, only the factor directly below the exponent is going to be repeated. So in this case, we have a 7 and then a w and a negative 4. And the negative 4 only refers to the w because there are no parentheses around. So let's say both the 7 and the w. So what we learned is that if this whole thing is really over 1, then the thing with the negative exponent gets flipped upside down. 7 has a positive exponent, so it is fine where it is. So what happens is the 7 stays in the numerator on top. The w to the negative 4th moves to the bottom and becomes a positive exponent. That's the reciprocal component. So you get 7 to the w, or 7 over w to the 4th power. Okay, number 2, similar concept. If this is over 1, the 3 has a negative exponent, the x has a positive exponent. The one with the positive exponent is happy where it is, so it stays on top. This goes to the bottom. 3 to the negative 2, the negative exponent, when it flips upside down, becomes positive. And now, because we know what 3 squared is, we can evaluate that. And so we'll get x to the second over 3 squared is 9. Okay, so 2 to the, number 3 now, we have 2 to the negative second power. Because there's a negative exponent, it's not happy, it needs to get flipped upside down to become positive. So really this is just turning this whole thing. Now when it flips upside down, when this goes to the bottom, there's nothing left, so it needs to be replaced with a 1 as a placeholder up there. And this becomes 2 to the positive 2. 2 to the positive 2, 2 squared is 4. So we have 1/4. Okay, number 4. This is a little bit new, but we're just going to be following the same concept, and that is, if you have something with a negative exponent, it needs to be rewritten using the rule as a positive exponent. So if, when it's on the numerator, it goes to the denominator, like on number 3, here on number 4, it's already in the denominator, so to become positive, it's just going to move to the numerator. So wherever it is, if it's negative, it flips to the other part of the fraction. So this becomes 2 to the positive 2, and then on the bottom, there's nothing left, so we'll leave that as a 1. Well, 2 squared is 4, and 4 over 1 is really just equal to 4. Okay, continuing on to number 5. Same exact concept here. W to the negative 4 needs to move to the top to make its exponent positive. When it does, it leaves nothing on the denominator, so we're going to leave that as a 1. And when you have a denominator of 1, it's not necessary in the final answer. Okay, on number 6, we have a negative exponent on the top and a negative exponent on the bottom. So neither of these are happy where they are. They're both going to move, and they're essentially going to switch places. So the x to the negative 2 moves to the bottom and becomes an x to the positive 2. The y to the negative 3 on the bottom moves to the top and becomes a positive y to the positive 3. And really, that's all you can do. Everything's positive exponent, so it's done. Okay, on number 7, just need to be careful with when you have a negative number, that's okay. Numbers can be negative, but that negative 5 is not an exponent. So it's just a negative 5, and negative 5 can stay where it is. But the k to the negative 2 on the bottom needs to move to the top. And what that looks like is the negative 5 stays on the top. the k to the negative 2 comes to the top and becomes positive 2. There's nothing left on the denominator now, so there's just a 1, which in the final answer does not need to be there. Number 8. We have an r to the negative third on the top. It's not happy with that negative exponent. It needs to move to the bottom. Now you can see when it moves to the bottom, you have a 7, which stays there because it's perfectly happy. Now the r becomes a positive 3, and now there's nothing left on the top, so it needs to have a factor of 1 as a placeholder, and that's all we can do. So there's our final answer. Okay, number 9, we're going to remember that any number to the 0 power is equal to 1. So really, that a to the 0 there is just going to be equal to 1, and that's something we can do right away. Now the b to the negative 2 is not happy. It needs to move to the bottom. The c to the negative 3 is not happy. It needs to move to the top. And the d to the 6th on the bottom is perfectly happy because it already has a positive exponent. So the a to the 0 becomes 1. The c to the negative 3 moves to the top and becomes c to the positive 3. The d to the 6th stays where it is. And the b to the negative 2 comes to the bottom and becomes b to the positive 2. And just tidying it up a bit, the 1 on the top doesn't really make a difference, so we'll get rid of it. And so we have c to the 3rd over d to the 6th, b to the 2nd power. And last one, number 10. You can see that the 5 to the negative 1 needs to move down. The a to the 2nd is happy where it is. The c to the negative 3rd needs to move up. And so the a to the 2nd stayed. The c to the negative 3rd becomes c to the positive 3 on top. 5 to the negative 1 becomes 5 on the bottom to the positive 1, which is really just 5. So cleaning this all up, you get a squared c to the 3rd over 5. Okay, so take good notes. Make sure you pause, rewind if you need to understand something better. And if you have any questions, just reach out.